Again, welcome to our next lectures, which cover the queues data structure. Our main objective is to learn about queues, also examine various queue operations, and also learn how to implement a queue as an array. In our next lectures, we are going to learn how to implement a queue using the linked list. That's the dynamic data structure. As we said earlier, array has a face size, so it's a static data structure. So what is a queue? Same as when we visit a supermarket or a bank. And when I get into the queue first, I will be served first. So a queue data structure is first in, first out. And here we say the definition is a data structure in which elements are added to the rear and removed from the front. So it's a first in, first out. Now, operating system often maintain a queue of processes that are ready to execute or are waiting for a particular event to occur. But normally, operating system use something we call the priority queue. Cover that in our next lectures. Normally, priority queue is still first in, first out. But if any task has the highest priority, then it's going to be served first. Also, here we say computer system must often provide a holding area for messages between two processes. This is normally called a buffer. So two programs or even two systems. Our software queues have a counterpart in the real world queues. As we said earlier, such as visiting the supermarket, or in this case, waiting in a queue to buy a pizza or enter a movie theater. Now, data structure in which elements are added at one end called the rear. So normally we join the queue from the back or the rear, and also deleted from other end called the front. So as we said earlier, queue is first in, first out data structure. As in stack, the middle element of the queue are inaccessible. So if you want to access anything in the middle of the queue, then those who are in the front must be removed first before the middle. So these are the possible queue operations. Again, here we are doing array implementation. First, we can initialize a queue. We can also check if queue is empty. Now, since we are doing array implementation, the size is static, face is a face size. We can also check if there's a space in the queue. Then we can check the front and also the back of the queue. We can add elements into the queue, or we can delete an element from the queue. So let's start with the queue exception class. So adding an element to a full queue, or this is again a re-implementation. There's no space in the queue, may cause an exception or an error, which we normally call will be overflow. Or removing an element from an empty queue. This is also may generate an error. We will call it underflow. So Java, again, here we are using Java implementation. Comes with a built-in exception for queue overflow exception and also queue underflow exception. Classes that handle these exceptions are queue exception extend to the runtime exception, and also queue overflow exception normally extend to the queue exception, and also the same thing, queue underflow exception also extend to queue exception. Again, this exception is built in Java system. So implementation of a queue as an array. Here we need some instant variables, an array to store the queue element. We also need a queue front. This will keep track of the first element in the queue. And also the queue rear will keep track of the last element in the queue. Then since this we have a re-implementation, we have a special variable for the max queue size. This will specify the maximum size of the queue, which depends on the size of the array. So this is an example of a re-implementation of queue. So first element A, index 0, the last element will be 99, index 99. So this means the queue size is 100. Now the queue front will be 0A. Here we have only 3 elements, so the queue rear will be 2, index number 2. Next, after delete queue operation, we may have, let's say we have Q front 0, and that's again, the 0 is the index, and Q rear index 2. Now, when we do a delete operation, as we said earlier, we remove from the front and we add through the rear. So again, problem with this implementation is that array have a fixed size. So after various insertion deletion operation, the Q rear will point to the last array position, giving the impression that the queue is full. Solution, we have to slide all of the elements towards the first array position. In this case, we are going to use what we call the circular array. Now let's go back to this diagram. Let's say, for example, we had ABC. When we remove A, which is the front, there's no any shift, so 0 becomes empty. We remove B, index 1 become empty. But we had a lot of items, and now we have item in 99, but 0 and 1 is empty. But since we reach index 99, it may look, if it's a linear regular array, it means there's no space. But we have 2 space in the front. So the best way to solve the problem is to have a circular array. So in this case, instead of having C as the front, we're normally going to join, it will be a circle. Actually, let's see the diagram here. So it will look something like this. So in order to solve that problem, in this case, there will be always, the only time there will be no item, no space, means we have 100 items from 0 to 99. So that's the example here again. From 0 to 97 is empty, but we have X and Y. So now the front become X and the rear become Y, or 98 and 99. What we are doing in this case, from 0 all the way to 97 is empty. It's empty. So best way to solve this problem again is using a circular array. So Q after one more hard operation, 0. So now instead of Q rear 99, the rear now becomes 0. I'm talking about the index 0. So this is the concept of circular array. So now let's go through the coding. So first we have a default constructor for our Q class. In this case, we are doing the array implementation. So we set the max Q size to 100. So the array size will be 100. This is again default constructor. So we initialize the front to 0 and the Q rear to 99. The index is 0, 99, 100 items. The count will be a special variable that will give us always it return the number of items we have in the queue. So for example, if we insert an item in the queue, we are going to increment the count by 1. If we remove an item from the queue, we are going to decrement the count by 1. And this is a re-implementation. So we have the list using the template. The max queue size of the array is 100. So next is to initialize the queue. Now, constructor normally we call it when we are creating a new object. So when we create a new queue object, the size will be 100. The front is 0. The rear will be 99 in this. Now, initialize queue also works the same as constructor, but the concept of initialize queue is that after we use the queue for some time, we have an item inside, etc., we can initialize it to empty state. That means deleting all the item in the queue, but we are not destroying the queue. So this is the circular queue. We can see the counter start from queue front, which is beginning, and we don't go more than queue rear. So if it's 0, and the size is 100, we go from 0 to 99. But when we increment I equal to I plus 1, we also have the modulus max queue size. This means when we reach the end, we have 99. 99 plus 1 is what? 100. 100 modulus 100 is what? 0. So this means if you reach 99, the index will start from 0 again. So this is the whole concept that make it a circular array. So let's say, for example, it's 97. 97 plus 1 is what? 98. 98 modulus 100 is what? It's 98. So it will be in the same index. 99 the same thing. 99 plus 1 is what? 100. So 100 modulus 100 is what? 0. So that means the index will go back to 0. But from, let's use 50. 50 plus 1 is 51. Modulus 100 is 51. So we're still in the 51. So that's how we, again, implement using a for loop for the circular array. Now we initialize the list to null. We make sure the front is 0 index and the array is 99. And also the count is 0. So basically we destroy everything, we remove everything. And we use the for loop to go through all the items. Set it to null, set the front to 0, the rear to 99, and the count is 0. Now let's check the is empty and also full queue. Is empty means we check if the count equal to 0. If the count equal to 0, we return true to the function, which means there's nothing. Now, if it's false, it means it's not empty. Same thing applies to checking if there's a space. If the count equal to 100, that means there's no space. So count equal to 100, we check. If it's true, that means it's full, no space. False means there's a space. Then we have a method for the front. So here we are checking if the queue is empty, we are going to throw an exception on that flow. Other than that, we want to see what is in the front of the queue. So we'll return the list queue front. Same thing with the back. And the same thing we check if there's something inside the queue, if we have an element. If not, then we don't need to return the rear. So here is to return what is at the back or the queue rear, the element. Next is add a queue. Again, this is an array implementation, so it's very straightforward. First, we check if there's a space. If it's full, which means there's no space, we throw an exception. But if there's a space, then we are going to increment our counter by 1. Then we assign the new queue element to the array queue rear, so it will go to the back. Same thing if we are removing, deleting. If there's nothing inside, then we try to delete, we're going to get underflow. So we check if it's empty queue, then we throw the queue underflow. Other than that, we decrement the counter by 1, then we set the queue front to null. Remember, deleting is from the front, adding from the back. So we set it to null, and then we say queue front equal to queue front plus 1 modulus mass queue size, which means we move forward once. So here we say use the mod operator to advance the queue front because this array is a circular array. So that will be the conclusion for this lecture. Again, this lecture, we went through the concept of queue data structure, first in, first out, and also the array implementation, and some of the operations we can perform. For example, moving an item from the array, normally we remove, in this case, sorry, it's a queue, but the array implementation of queue, normally going to remove from the front. It's adding an element into the queue, we add it from the rear. So again, if you have any question, send an email. Thank you.